Welcome to another test and teardown video. Look at this big unit. I don't know. I think, and this is the top cover. It's also made in steel. This cover alone is 4 kilos, including the cable and test probe. This unit is from Rohde Schwarz Polyskop 2 type SWOB. What the heck is that, huh? Polyskop. It is in absolute mint condition. There are no marks and scratches or anything. It's really nice. So as far as I can see, we can set up some frequencies, some lines, center frequency, sweep width, and when you go up to 1200 or 400 to 1200, I guess then this one will be used, because this one covers the 400 to 1200 range. I don't know exactly what is gonna happen if you are between 300 and 400, then it's maybe locked. I don't know exactly what is gonna happen here, but I think this has something to do with the sweeps and stuff. And then there's a output attenuator for the level and a fine setting for that, I guess. So we got an HF output. That is of course for the screen, the brightness and stuff like that. And this will be the RF input. But there's also a test probe detector, but it is not only in one channel. So this is the first channel, but there's actually 2 channels on this model, and you can turn on and off each of the channels, or you can A, B or something here. So vertical gain for that, and then you set some frequency markers and how powerful you want the markers. So yeah, I also got the probe for it. So I guess diode probe, yeah, exactly. So this one will convert RF energy into a DC signal. And as far as I see, this is a passive probe, so there will be a diode of some sort in here. I don't know exactly what's gonna happen here. Maybe we need to look in the manual. For that connector fits real good here. Then we got the on and off switch. Oh yeah, I forgot to say, I think this one is from 1950, in the middle of the 1950s. So it will be an all tube device, and its size is it is a new record in size in 1 unit. This one alone is 58 kilos. So plus the 4 kilos here, that is 62 kilos when you carry this. And this is why you will see 2 big handles in each side. So it's a 2-person lift, even 2 persons carrying with 2 hands each. It is still a very good load per person. 62 kilos, that is 136 lbs, folks. So I need to put this somewhere and see if it works. Oh my goodness, I need a vacation. The case here, the shell here alone is 13 kilos. It is that big. I think I could even crawl in here and hide. This is the size, guys. You can definitely build. You can hide somebody there. So this is oh sorry, it's upside down. This is the external marker input. That will be the fan. And sweep direction. So there's a switch here where you select to go down and upwards. I don't know why you would like that, but anyway, it supports that feature. That's pretty cool. And we are in. This is really a big unit. And I think I am the first to look inside this unit. There's actually a few evidences. Oh, I don't know if I can show you guys this, but this will be the screws from the front panel. If you look here, they're super mint. Look at this tiny little mark there is there. This is actually from screwing it tight, not from opening it. So there are no marks at all from opening. And I just opened it. So I didn't even leave a mark. Normally I see screws with deep marks of abuse, and they are really big, and they were really tight. So that is one proof, and another is original label. It says here the warranty label is from '68, so we definitely know this unit is from '68. 6 month full warranty on the tube. Only 6 months. Oh, look at that! Oi. What is that? A little black bag that was tied to the back side of the fan. Oh, and the fan is hanging. Nice. It's actually getting a little bit low on those over there. That is one sexy fan. But yeah, spare fuses in a little bag. Ain't that cute? And we got all sorts of funky stuff here. That will be, yeah, the frequency adjustment with a very long thingy. I can't wait to go and play with this and figure out what is in here. But first, we're gonna see if there's anything bad or wrong or loose or anything broken. If we can't see anything, I'm definitely gonna power it up. So that will be the attenuator. We've got 2 different attenuators and semi-rigid cables. Everything is just made amazingly good. They knew what they were doing. I guess this, we also got some transistors, or at least diodes. Maybe this is a diode or some stuff. I had the idea we would see only tubes. That relay. Oh, look at that. What have we got in this? In here, I think we got some of the funky stuff. We're definitely gonna go and look in there. The reason why I'm crawling around here on the floor is this thing is still really heavy, and I need to go and figure out where to put this tomorrow. And that will be the high voltage power supply. This is the sweep direction. This is where we cannot touch. And that will be the connector for the external marker input. And look, they even put a plastic marker here with RS. Yes, we can have a look. So 7/16 connectors. That was like really pro. We got some voltage regulator tubes. We actually got quite a lot of tubes. Oh my goodness. It is just packed with tubes. Oh, I'm definitely gonna count how many. but that is a whole lot. Look at that. And we got a shielded case around some of it, and some of them they are not. That's just voltage. And this tube is a really, really interesting tube. It is huge. But I think it's a static deflection tube. So we need to have a little look in here and look at the thickness of this metal shielding. Oh, it's beautifully made, and that will be all those wires there, some connector where we can disconnect some stuff, and that is something really, really special. I'm sorry the picture is turning around here. Oy, oy, oy. I was reading a little bit, and I was a little bit worried about what the heck is that. Can we figure this out? So we got some inductors and a tube in the middle here. So what exactly are they doing with magnet fields and tubes in the middle and some stuff? That is something we have to figure out by reading in the manual or the schematics. This is really, really funny. Maybe it's this goes through here, and then it's maybe all the cool thing is inside the box behind here. I don't know. It's oh, we got a big selenium rectifier. We got another big transistor down there. Tons of capacitors down there. Wow, there's a lot to look at. Will be all the knobs and switches, and again, shield. We can easily go in here. Can I move it? Yes, I can. And here we got voltage selection. Oh, we got a little bit of corrosion here. This I need to clean up and fix before we can run it. Mains transformator is huge. Everything here is just made fantastic. Wow, man, this is just high-end 1968. The best the Germans could make in 68. I'm telling you guys, this is, every time I look into Rohde Schwarz gear, it's just amazingly beautiful. This one, look, the thickness of stuff. Some solid goody things in there. So now this thing is on the table. It is still really big. It is now, of course, outside of the case, and the case was 12 kilos, so that means this is what, 58 minus 12 is 46 kilos. So yeah, I needed one of my kids to help me carry this up on the table. But I think I'm ready to power this up. Mains here. Plug this in and prepare. Okay. Let's just do this. What? Not a whole lot is happening. No! What did I do wrong? This is on. Okay, so we have a faulty unit. I need to look at this. Damn it! Okay, fuse was blown, so now I'm gonna start with 0 volts, crank this on, and then I'm gonna plug in the connector. I always pull out connectors when I operate fuses, not just turn off stuff. Pull the plugs, that is kind of what I do. So, going to crank up the voltage real fast. Let's see what happens. It was with a 1 amp fuse. And we got 200 and... See? It's actually using more than 1 amp. So the fuse is going to blow again in a minute. But the fan is turning around. Look at that! Hey, hey, hey! What is that? We got a picture. What? That is a beautiful picture. Okay, that will be the markers, right? Yeah, that is definitely the markers. So I can adjust how much I want the markers to be. Wow, man, that works. It really works. Wow, that is a beautiful picture. And I didn't even turn the brightness is here. Illumination, that does not work. And the focus. Wow. I will of course play a lot more with it, and then I will come and make a better video, but hey, yay, we are alive. Now I've been playing a little bit more with this unit. I found the calibration cable or the shorting cable, and there's absolutely no change whatsoever when I connect this cable. Also, what I see here is the 2 inputs. No matter what I do here, I don't have the possibility to change the height of each of the 2 input channels. So I believe there's definitely something about the vertical input here that's not working. There's a bulb that is not working in the illumination. Also, I found, let's turn on a little bit of light here. I also find the frequency ranges. See, in the different frequency ranges, you can change the sweep width here. I got markers turned on here, so we can see what's going on when I turn the width, and then I can move the sensor frequency here, and that kind of works for all the different ranges. But the 400 to 1200 megahertz, it goes dead. So that is this special oscillator up here, and then you need to turn that one on and off, and I see no current consumption change whatsoever. So that means we got a dead oscillator in this the high frequency range here. That's probably just the tube or something. I'm gonna see if, or maybe there's a fuse. So I need to play a little bit with this, and of course the vertical system that is not working at all, I need to play with this. I also need to take my spectrum analyzer and measure if there's actually stuff coming out, because that is obviously required to be able to detect something. But as long as it's reacting, see, to all this, that means something is oscillating and something is mixing and something is displayed. So yeah, definitely. There's a funny sound from the fan. And I'm gonna go through all the different tubes, which ones are lit. Will I find one without filament? Oh, voltage regulators tubes, I love them. They glow so nice and beautiful. Let's turn off the light. Let's maybe dim this one as well. And we can see much more clearly how it looks with all the bulbs. Ooh, you can definitely feel the heat. It is really, really hot in here. But it is using 250 watts. 250 watts, yeah. That is a lot. Oh, and by the way, when I started the intro, I was having a wrong idea about the CRT. Because look, you can actually see the coils. So that means we have a magnetic deflection system. It's just really small, but it's definitely not a static one. You can see it. So I better correct myself before somebody else will do that. By loosening those two screws, you can move down the light bulbs, and then look at this. You just lift up like this, and now you can clean it. And now you'll also get access to the screen and can clean the screen. Ha! I'm gonna go and replace the broken bulb. I'm trying to have a little bit better look of this. I think this is the Diode rectifier probe. It looks a lot like that. Here we got some specifications and some stuff. Already started to pull it a little bit apart. It's real easy to unscrew everything. It looks like this is the connector piece for stuff, and they have been cutting this. Doesn't look like this is maybe how it's supposed to look. So the ground is a flat piece of copper that's silvered, and then there's this really nice way to do it. You just push it, and then it can be moved back and forward or rotated, so it's easier for you to work with it. And there's a 4mm banana connector here as well. So that is very good. I can see some stuff in here, some components. I guess there's a resistor and some other parts. I don't know exactly what that is. So, and we're two screws here. Let's open it a little bit more and have a look. Right? It is amazing. Really good build quality all the way. I am actually a little bit impressed. So I guess this will be the diode we see here, right? Or is it in here somewhere? Because maybe this is a feed through. Yeah, maybe this is the feed through, and then that means the diodes. Yes, that is the diode. Because there's a diode symbol, right? So yes, this is how it works. So this seems like this diode is in some sort of a socket. Wow. But this is beautiful, and it actually works. So we just leave it as it is. Yeah. Now I have assembled the probe again, and now we can make a little measurement with it. So I've been doing a lot more tests on this unit. I've been playing around with all the different inputs and settings and stuff, and I think it's actually working. See, if I turn on the different channels, it is in alternating mode, the two different inputs. I don't know if you can see it's now it's not blinking so much, but if I turn the other channel on here, it's now blinking. So that is how it is, yeah, alternating between the two input channels, so it doesn't measure exactly at the same time. But it doesn't matter, since the output signal, the stimulus for your measurement, is just coming every time. So that is not a real problem in this case. What I've done is, see, I put on a scope so I can see the signal here, and I am in the lowest frequency band, and then I can play with the different way it zooms in and out here, and whatnot with the sensor frequency and everything, and then I can see how it changes the pulse on the scope. So that seems to be working really good. Also, I can take this probe and turn this on, turn this off. So now I take, so this is the probe, and if I connect it, see, here it is, and then we see some signal. I think it's difficult to do this at the same time, and as I'm doing a little bit more signal here. Ooh, yips, that was too much. A little bit less, see? So here we go with the signal. And also, see what happens if I connect. You can see it's not really flat here on the top. I can also turn off the markers. What I'm trying to do is get the ground on. See, now what happened is I got the ground on, so it's quite flat. And if I remove the ground, I got, see, all sorts of reflections. So yeah, I definitely think it is working. I am now in the 0.5 to 50 megahertz range, and I cranked this way all the way up to max. And I just connected a spectrum analyzer using like the hooks. What I got here is a 0 to 100 megahertz. Let's take a max hold. What we see here is, of course, interference between the scan speed of the spectrum analyzer and the scan of the pulses that comes from the unit. But if we just wait long enough, of course, we're going to see the maximum or the sweep pulses, and they come, of course, in sync with mains frequency. Everything in this unit is, of course, mains sweeped, and this is a really genius way to do it because of many reasons. Because we are running with a very big CRT, and this is very sensitive to make. Oh, that was the fuses. Fantastic. Let's try and do the same with the next range from 50 to 100. I am again here in max hold, and let's use the marker. So it goes from what, 44 and yeah, 44 to 108. So I think it is very close. So I think I will try and do this with all the different ranges. Then I crank it up. This is 100 to 200. And then I need to check. This is the next range, 100 to 200. And it goes from 87 to 214. It's not really super duper flat anymore and all that, but okay. What do you expect? I'm just doing this because I don't have anything that fits this special connector. And the next range, the 200 to 300, goes a little bit from 179, so it's a little bit off, right, to 233. So it's not exactly accurate. I think it is just not supposed to be that accurate, really. So the 300 to 400 range goes from, what is that, 281? Oh, I'm too slow with the marker here. And it is 425. So I'm now in the 400 to 1200 range. And I think you need to remember to turn this on. It's not done automatically. So I guess there's maybe something wrong with the switch here or something. And this one is what, 500. So you can, okay, you can dial this to 600. But you see, it's totally flatlining here, so there's nothing. So what I'm going to do now is I'm investigating if this switch is actually affecting anything in this circuit. There's this is where the oscillator will be. So this is some mechanical piston that will go in and out and make this resonant chamber bigger and smaller. And I believe what you see down here is the sweeper. I think it is actually like a speaker or like a membrane that moves up and down in mains frequency voice coil kind of way, or maybe it's a piston as well. I don't know. As I can't really hear anything, and there is no vibrations or anything like that. But that is actually how they made the sweep, by mechanical movements. It's really fantastic. We're going to have a little bit of a look. So this is the right side of the unit. Look how beautiful this is made. Everything is really neatly numbered. So I think they glue the numbers and then they add a little bit of varnish so we can see how it is. And all the capacitors, they're mounted really well so they're not moving. See, they cable tie everything. It's just really, really good made. So there's a shield around the different input gains and on off and enable and all that with the input, and that will be all the markers. And relays for the different features of the amplifiers. This is inversion or one of the two outputs of the amplifiers. And look at those diodes up here. They sit in like a socket. Aren't they just beautiful? Let's have a look. Oh. DS332. That's a beautiful diode in a socket. And some capacitors here, like everything. See, every little resistor is marked or capacitor, so it's just so beautiful. And this is the back side of the power supply, the voltage regulator, and of course the fuse, and everything. Again, they just mark everything. Nice. So this is the left side of the unit with all the different oscillators. Let's see if I can get a little bit more light in here. And that will be the 4 lowest oscillators we see here. And those are really special. Those inductors, as you see here, this is actually only, well, this is most of the inductors, but you see here, they go through the base plate, and I believe that will be the oscillator tubes. Let's try and look at the other side. Bottom side of those inductors. And look what we see here. So this is one of them, and this is the other one. And what you see here is a tiny little inductor in between the two halves, and this inductor is actually the oscillator inductor, and this one winding that goes around it is the output that goes to all the outputs. They goes to the output selector, it goes to the attenuator, and then output, right? So here we go, 4 different outputs and the 4 different ranges. You can of course see higher frequency means less windings. So I believe this one up here, or is it that one, with a lot more windings. Is that easy? It's not so easy to see. But the way that this works is that we put a lot of flux, magnetic flux, through this tiny little oscillation inductor. So we kind of overdrive it or saturate the core, and this way its properties kind of goes away, and then you change the properties, yeah, and the oscillation frequencies and all that stuff. So this is really how it works. It's a good old principle. So this is how the different that was the oscillators. This is the high frequency oscillator that works from 400 to 1200, and I believe the tube is in here somewhere. Maybe we can look here from the bottom to get access to the tube. I'm going to measure some of the voltages here. I believe they're probably missing, or maybe it is the switch. This is supposed to be the on-off switch for this range, and where is this going, and what is this? So I'm gonna figure this out. And what we have here is all the different things for the sweep. Some alignments and stuff. We're definitely gonna go in here as well and have a look. And that was the left and the right sweep. All this down here is high voltage for the CRT. I don't believe there's anything super fascinating to see in here. Maybe some ultra high voltage rectifiers and stuff. Maybe we should have a little look. This is probably some stuff for the CRT. Look at those capacitors. That is the meanest ceramic. Oy, 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 oy. Those are badass. Some really, really high voltage stuff. I love it. Those are really nice. Can't really read what it says here, right? How many volts and how many this and that, right? 0 point something and whatnot. Hey, could be fun if only we could see. But maybe we could just look at the schematic, right? Well, that is definitely CRT voltages. I believe is it 12 or 14,000 volts this is running on. So there's probably also some nasty rectifier diodes and stuff in here somewhere. I already found the bug. So this is the on-off switch for the high frequency oscillator part. And this is definitely the tube that's in here. And we've got no filament. That will be the low voltage filaments. Because this one down here is a plus 200 volt. And this is always there. So we got 200 volts. And what we got is, this is the connector that goes to this tube. And here is the other end of the connector. And let's see this wire. That is the filament. Right? Goes to this resistor. And this wire here goes to the switch on the front panel with the 6.5 volts or something like that. And this voltage actually go on and off here when you turn on and off the switch. So that is fantastic. But there's 0 volts on this point all the time, and this is the voltage that goes to the tube. So this switch is not, or this resistor is not working anymore. So that is the problem. And if you look real careful, this is the end of the windings, supposed to be connected up here, where the output is soldered. So I think what I can do is move this wire to the other end of the resistor and then just dial this down here about the same distance, and then it should work because I got voltage on this point. So I moved the wire down to the bottom part of this resistor, and now I got I got filament for this oscillator. And I can see when I turn on this oscillator that it is using I think it's almost 20 watts more. So this part with only one tube and what else is involved in this actually uses quite a lot of power. But anyway, let's look at, oops, let's turn this off. Let's look at the output. See, this is now 1 gigahertz center frequency. And this is the sweep width, and it is all the way down to the minimum. So now let's look at the minimum, and then I crank it up slowly, more and more and more, and all the way to the maximum. Now you can see there's a lot wider sweep width. So my span here is 300 megahertz. So this is the widest, and then I go down to the smallest. And of course, all this works really accurate. I got 1 gigahertz here, and it's because it's a mechanical system with dimensions that makes the resonance. So this will be accurate a million years, right? So now I got this whole unit out on the table, and it looks really fantastic. I think it is quite clear this unit is the modulator or the sweeper. It says here magnet something, right? So it's a magnet factory, right? Dortmund, so this is German, right? So we're going to figure out how we open this. And yeah, here is the anode. I don't know exactly why the anode supply is here, but I think it's because it goes up and down inside this slider. And here is the frequency readout. See, somebody even wrote here by hand the dates it was tested or calibrated or something like that, right? So of course we're not going to take or move the dial or anything here, because this is the calibration. You loosen this and twist it. But we're going to take this cover off first and see what's in here. Yeah, and that is the output. So there's definitely some sort of a pickup in here for the output, and I bet this back screw here is probably access to the tube. With this cover removed, we can see how the frequency adjustment works. And look at this screw here is the backslash adjustment, and it is actually a little bit to the loose side. I can feel when I move it here, there's a little tick tock. Not a lot, but so what I think I should do is, it was loose, so like this, and then it gets, so now it was actually that easy. Cool. All right, I took off the bottom cap. Let's have a look what is in here. So it is not easy to get access to the tube. I really would like to see the tube. So where is it? And what is in this thingy? I bet we're not supposed to access the tube, huh? Now I managed to pull this whole oscillator part to pieces. So this is, the oscillator, the sweeper. And this is actually just like a loudspeaker. You see the voice coil here, and this one is moving. And so this is actually a variable capacitor, because this is the part. If you see this little inner part here, it fits into this hole, and this outer part here fits into this outer part here. And this forms a variable capacitor when this is moving. So this part here connects into the anode part. See, because this one is screwed on top of this, and there's actually a tiny little piece that goes on top of this. This part together with the spring, and here those contacts, they kind of goes all the way around here with the spring in between, right? So this pushes up. And then I don't know exactly how I put this back in here, but it's going to be a little bit difficult to get this in here and not drop this, but I'm going to do it upside down, of course. So when this is mounted here, I can assemble it all again. Also, let's look a little bit on the voice coil assembly. If we look in here, we can see the yellow and the red wire. So I believe they will be on the bottom side. This is a very, very beautiful voice coil, or like a speaker construction. It is definitely made for linearity and all that, because you look at the springs here, and then there is an adjustment screw here. So the whole idea with this is you're able to tighten or loosen this screw and move the entire magnet a little bit in and out, so you can adjust how this is moving. Isn't it just fantastic? And then there's a feed-through capacitor here, because obviously you'll get all the gigahertz to this capacitor, right? Because the center of the capacitor touches this metal, and if we look a little bit in here to the right, we can see the isolation. So this will be the grid that is connected to the metal. This is the end of the variable resonator, and the center of the resonator here is connected to the anode. So this is the anode, and the bottom part of the tube, this is actually the end of the tube we see here. It is a tiny little tube, and the two inductors, that will be the filament. So that is how it is, a little tiny little tube, and it is really, really beautifully made. But I'm not going to disassemble it more than this, because I really want this to work again. So now I can put everything together, and hopefully it's gonna work. And now you know how they did this.